everyone, welcome back to Club Phoenix. My name is Remy Chalkakar, and today we're going to be doing a really cool experiment called Fizzing Jupiter. Hope you enjoy! So, just as a heads up, you'll be needing a mixing bowl, any kind of vinegar, some baking soda, some water, a measuring cup, and watercolors. Preferably liquid watercolors, but if you don't have those, then you can just use the kind I have right here. If you have this kind of watercolors, then please remove the palettes of red, orange, and yellow. Now, take these individual palettes and carefully break them into smaller pieces. Make sure that they're around this big. Now, take these palettes that I've shown you right here and put them into water. There should be around this much water. Let them dilute for a little while. You can stir it with the paintbrush to move along the process. Once the water looks significantly yellow, you can remove these small bits of paint that you have left here and use them for a later date. Now, use these other colors and put them in the water until you see the color that you want. Then, use a paintbrush to take them out. This is the color I'll be using, but you can use any one you want. Take 1/3 cup of baking soda and pour it into the bowl. Now take your liquid watercolor and put it into a measuring cup. Then fill it up with water until it reaches 1/8 of a cup. Remember, 1/8 of a cup is half of the 1/4 line over here. Now pour it into your baking soda. Okay guys, be really careful during this part because it can get a little bit messy. Your bowl should look like this. Now stir everything up until it has kind of a mashed potato or ice cream texture. This is what it should look like after it's fully stirred. I want you to put your spoon in and grab out the most solid parts, like this. Then put them on your plate. Take it into your hands and then mold it into a planet-like shape, or a sphere. Then put it on your plate. If you want to make yours a little bit more colorful, you can kind of rub off a little bit of this. Now, put the palette on the side and then kind of put this on your hands and then pat it around. So, this is what my Jupiter looks like so far. Now, measure out 1/8 of a cup of vinegar, any kind of vinegar. Okay, this is the moment that we've all been waiting for. This is what the atmosphere looks like on Jupiter. Keep in mind, this is not really what Jupiter's atmosphere looks like. It's more of a cool visual representation of what a model of it might look like. So, this was not meant to teach you guys really about Jupiter, but more about the reaction between baking soda and vinegar. So, in previous videos, we have gone over how everything is made of atoms, and everything is made of different kinds of atoms. For example, people and dogs and trees. They're all made of atoms, but they're all made of atoms that are slightly different from each other. And that's what makes them look different. So, in this reaction between baking soda and vinegar are also made of different kinds of atoms. And when both of them come together, they combine to create an entirely new mixture by exchanging atoms. This is called a reaction. And in this reaction, carbon dioxide is released, and carbon dioxide is the gas that you see. This happened because baking soda receives a proton, which is a smaller part of an atom and it has a positive charge. This leads to it transforming into water and carbon dioxide. If you want to know more about protons, I really encourage you to go back and see some of our previous videos. Then you might gain a better understanding there. So thank you guys so much for coming, and I hope you enjoyed this experiment.
Hey guys, it's Aria from Club Phoenix. Today we're going to do the lemon volcano experiment. First, you're going to need a lemon, some baking soda, a large plate, either 1 or 2 food coloring bottles to give the bubbles some color, a butter knife, and a spoon. Okay, so let's get started. Begin by putting the lemon on your plate. Now, cut the lemon in half. Ask an adult to do this part for you. Next, take your knife and scoop some of the inside out. This should also be done by an adult. Then take the spoon and mix the insides of the lemon like this. After the inside of the lemon is definitely scrambled, put a few drops of food coloring inside it. You can use 1 color, or if you want, you can make 2 and put a different color in each one. Then pour some baking soda onto it. It should look like this. You might see a little bit of fizzing already, but before too much bubbling happens, mix the baking soda in. Wow, look how it's fizzing onto the sides. It's so cool. And here you go. This is the final product. You might be wondering how this happens. Well, this occurs because a lemon is a citrus fruit. Citrus fruits are very sour and they have something inside them called citric acid. If you couldn't tell already, citric acid is a type of acid. Baking soda, on the other hand, is a base. When it comes in contact with citric acid, it starts a chemical reaction. That causes all the fizzing and the bubbling. That's it for now, guys. Thank you so much for watching. I'll see you next time.
Hello everyone, my name is Swaksha Mehta and today we're going to be doing a star toothpick experiment. So let's get started. For this experiment, you're only going to need a plate, some toothpicks, and a cup of warm water. The first step of this experiment is to grab 5 toothpicks and start bending them in half, like so. These are what the toothpicks should look like after you're done bending them. The next step of this experiment is to grab all 5 bended toothpicks and start aligning them together like so. This is what it should look like after you're done arranging the 5 toothpicks on the plate. Next step is the fun part. You're going to grab your cup of water and add a small drop of water in the middle of the toothpicks, like so. Make sure not to add too much water. After a couple minutes, your toothpicks should look something like this. They arrange themselves into a star. Isn't that so cool? So what exactly happened during this experiment? When the water is placed in the middle of the closed star formation, the wood begins absorbing the water, causing the wood to expand. So, as the wood absorbs more of the water, the bent wood fibers expand and straighten out, pushing other toothpicks against one another. So, as the toothpicks straighten out and push against each other, the star opens up.